Okay, we can again start our next lecture. Some of the recent TSF failure. So there are so many failure have occurred, and so we will again see few of them just for an example and see like what exactly happened there. So this is kind of a distribution where it is occurring. So this distribution is telling me that is the distribution is random. It is occurring everywhere. Wherever there is mining, there is some failings and there is some failure. It's not that some people are better than others. And we are like, it's like when I look at data, the US has more actually. So because they started much early, I think US has more because their data is available. Other part like US, Australia, beyond US, Australia, Canada, other part data may not be available. That's why this showing US has more. But you can see that's happening everywhere. Correct. So between 1910 to 1999, US is way above. So the reason is that in the US they always identified. Other places they never identified. That's why you don't see that. Because why after 1999 again US is same with the others. It's much less. But during that time it is more because they always identified. But you can see that next to is Chile, then Canada, UK, but again Asian countries are not there because they never identified. But this, they don't do that. So this is somebody who has prepared where you will do a literature review and wherever you find data you put that. So but again everywhere it is happening. That's what I'm saying. What are the causes? Found that initially the seepage, but again the seepage is still there. It's not that people initially was not understanding, now also not understanding. So the seepage issue is still there. And that is mainly because of our understanding. In our like soil mechanics textbook, not much is told on this pore pressure, on saturated flow. That is what is seepage. We are only studying in the steady state seepage, which is not happening. We are only studying about the saturated soils. That's not happening here. So our like literature is not good on that seepage part. That's why the seepage is still there, even in latest data. Always seepage is there. Then next is the overtopping, which is very common. Overtopping happens everything. Then also the others part. Again the others part we do not know, that's why it is others. It can be anything of this. Then the foundation failure also another important. That's why we focused on like if you have a clay foundation, you have to be very cautious on that. Because clay foundation is same as what's happening in the upstream techniques. Your foundation load it will be may create high pore pressure. So if you focus on the pore pressure, then a lot of these causes are bad. Again the overtopping also pore pressure is high, it is coming up and going. Oh. This is the one which tells the South America countries ban the upstream. But we do not agree with them, because we have not made any statement that ban upstream. But you have to do more. Like again, what I tell my client, upstream is less economic, yes. But instead of going to downstream, which is expensive, you spend money on monitoring and improving and observing and following all these guidelines given by these methods. So you spend money, and they are doing right now. They are still doing upstream and spending money. Rather than, because in the downstream the problem is the space, and most of your things you are starting from the boundary, so you cannot again go downstream. You are already stopped there. So though this data is telling upstream is the failure, but again you can see also downstream failure, also central line failure is happening everywhere, but upstream is more prone to failure. So it needs more monitoring and more cautious. That's why in upstream, have your dam much better than what you are doing. The dam is the structure there. Dam is protecting. Dam is taking load. It's not that this. So some people are not using good material in the dam. No, use the best material in the dam. If you go that direction, you will be good. And look into the seepage also. Again, they have like so many different failure mode, but again, here I wanted to show this again because the unknown is the highest. Lot of failures when they are analyzing, they do not understand why it failed. So that's why you see unknown is the highest. Lot of failures they say it's unknown, but again the earthquake, overtopping, then the slope instability are the major failure. So what happens overtopping? So when the overtoppings, so what you are doing? You are going over the structure, and in the structure if you have weak material, what will happen? It will all wash away. Most of the things you are seeing that also, no? It's overtopping, and then your structure is weak, it is washing away. So that's why focus the structure, do not use any weak material on that. And it is another study, but it is same thing, showing the unknown is the highest. Go to some of the actual what happened. This one happened in 1985. These are like very, I am focusing like some changed the nature and also make people more cautious. This is one of them. 200,000 cubic meter of tailings that flowed 4.2 kilometer at a speed of 19 kilometer per hour. No, that speed, like you see the energy of the tailings, we saw that. No? The energy of tailing is much more than the energy of water. With time, it increases, it flows much more higher speed, because when they are going, they are carrying more and more material in it. So it's killing 268 people, destroyed 62 buildings, 43.5 hectares. So it was devastating. So that's why when this happened, after that people are all like, oh, we have to, because us, and a lot of activities like what happened in 2019, this also lead to a lot of people were worried on that. The dams were constructed with an unacceptably low factor of safety, that the failure probably was triggered by a blocked decant pipe located in the tailings. So the decant pipe was blocked, like we are showing, the decant pipe should be there to drain it. So if that decant pipe blocked, the pore pressure increased, and then these people also thought that, like, again, the factor of safety is, like we are now saying, 1.5, but people were then using their own factor of safety. If they think that with low factor of safety also that dam is staying high, so why I will go more? So design guidelines were not there, so that's why. But when it fell, they found that's the cause. Then this happened in Hungary, is a red mud failure. 2010, a red mud fell, and 600 to 700,000 cubic meter of red mud and water, the slurry flocked the lower section of the settlement of this valley. 10 people were killed, 120 people were injured. The spilled red mud 1800 acres of the surrounding areas. The most severe devastation was caused by the villages which were located near the reservoir. Cause triggered by a shear failure of the dike at the seepage point located about 300 meters east of the tailings dam. They found there was some seepage, and again this is also due to increased pore pressure. Most of the things, the cause is the pore pressure. So you can see that how big area it covered. I think we have some more coming in this one. Then in the France 2004, again failure decantation and evaporation pond. The plant released about 30,000 cubic meter of liquid and slurries. The liquid contained high concentration of nitrate, elevated nitration concentration up to 170 in the canal of that where it went, while uranium concentration were remain unchanged. The dam failure is believed to be caused by abnormal presence of water. Again, everybody is saying the water. So here you can see that most of the before and after, like I wanted to show you like before what it looks like and after what it looks like. So you can see that this whole thing felt, which was looking very familiar before, and then it in 1998 in Spain. Also it has a displacement which was again with a diagram it is shown, like they found not only it fell, also it displaced. That part has come, the one go this way, this one goes that way. You can see that 60 meter of displacement. The dam itself displaced like 60 meter. So this is a typical one. 4.4 to 5 million cubic meter of toxic slurries. The slurry wave covers several thousand hectares of farmland and threatened a national park. It's a UN worldwide heritage area. It was very close to that. The pressure of tailings on the ground caused a large displacement of clays at depth of about 14 meter. So you can see that how before it was like this, and then this whole fell, and it also moved that dike. You see, that dike moved from this point to that point. You can see that how much the 60-meter movement. The dike was earlier there, now it moved to here, it is now found. And that is the pressure. That load, water pressure load, nobody knows that. Lot of, like, if you guys have a heart, like in the 70s, there was an underground failure somewhere here in Dhanbad area, underground mine failure. They couldn't locate the water. They were doing the underground mining. There was a water body there. Because of the fault, they didn't know where is the water. And when they go there and hit the water, because that water body, because of the mining, the pressure is very high, because when you block something, it's more pressure. So somebody tells us, like, when we, like in our body, sometimes we feel pressure, no? And when we go out and release our pressure, we see the flow. So if you don't have pressure, the flow is different, so you can compare that. Like, this is a small one, but you see, but the water pressure is, still you can see that. So you imagine, if a small water is creating that pressure in our body, huge dam, how much pressure it will create. So it moved everything and finished. So there is the water. This occurred recently, Chinoporos in Chile. This is 2024 last year, so you can see that this is the before picture and this is the after picture. But this one is I think this is a dry stack. So that's why it didn't go further, like it maximum went here only, like it didn't affect it much. That's why the dry stack and slurry can be different. Like the slurry, because of the water, the pressure is much more, and when it travels, you will find this in slurry will be in the movement, but it will not be that devastated. The failure occurred during passage of they are saying is due to high, like storm water. There was a frontal weather system that deposited about 100 millimeter of rainfall in a short time period. Then the TSF wall was fell. So again the water also, because of the rain, like storm water or poor pressure water, again the water also caused it. Because the tailings has been thickened, so this is a dry kind of pipe. We are not telling it's a dry stack, but definitely some thickened tailing. It's not the slurry. It appears from the image that there has been very limited mobility. So that's why people are going for this filter tailing. Because even if it fails, it will not go much distance like this slurry. Again, that's the one Hungary one. I am again showing it because this has some more pictures and also more important things we are seeing here. So you see this corner one, this is the bigger picture. You can see where it is going. This is the close picture. This corner one, it fell. So not that those ring dikes or they are better. So to me look like there are some white material here. Can you see that? So what is that white material? So definitely this structure is not built with a strong material. They might have used something, and that may be the reason. Again, it is coming from the alumina plant. Heavy metals, all. They say that this loss triggers an alkaline reaction on the skin. So it's not just the water. It can affect your skin also, that it's toxic. So Anybody has any idea like what is this alkaline in the sludge coming from the alumina plant?
So
You have
it is basically the sodium hydroxide which is present there. So it is caustic, what we call.
caustic water. That's
Caustic
what
water.
So caustic water can affect the skin.
Yes, it
Skin.
is. We call as caustic water as carnivorous. It can take off our skin.
Yeah.
It reacts with our body, eyes, everything, every part of our bodies.
Oh, okay. That's what somebody was telling that eye is.
Yesterday, Sarath
Yeah, he was telling the eye. So that's the caustic water.
So when we were working previously, sir, we did not know. So we were working with empty hand and also our head used to ache and then our eyes used to come out. Then we didn't understand what's happening. Even the image which you showed, that cow image, that is also from that red mud coming out. So the whole skin is coming out of that.
Okay.
So like acid eats away our skin, this caustic also eats away our skin.
Yeah. So.
So the entire skin may come out.
Exactly.
And if the caustic with temperature, it becomes more vital. So if the temperature is high, like 100 degree, 145 degree, 150 degree, like we operate in the plant, then it becomes much more hazardous.
Okay.
Like if the 150 degree this caustic falls on someone, then the entire skin, muscles, everything will
Be
repel
born.
and with leaving only the bones.
Oh, okay. So this is dangerous. So you have to be very cautious on this. Like you have to store it. That's why I'm focusing that dam structure. Do not make it weak. If somebody is telling you do that, no, it's my dam. I will, because if it fails, you will be the responsible. You see? So you think you are also engineer, you know how to build the dam. Like, so think is a dam. I need my good material on it and I will make sure it is stable. 4 people have died and 120 injured, but if I remember when I was reading that, most of these injured people have that effect, like skin and things like that. Yeah.
Caustic burn we call that.
Caustic burn we call that. You have seen that also in some of the
Yes.
failure? Okay.
In refineries we have some incidents
Okay.
where the caustic falls over the people.
No, but this tailings failure, you have seen anything?
Tailing failure there is not exactly, but only one the runoff water from this tailings,
Okay.
red mud dam, which was stored, that failed last year in Vedanta.
Okay.
That Muri, sir. Muniguda, sir.
Okay, I think I might have one slide there. Yeah.
So
okay.
there I was a part of.
Okay. Yeah, I have like she gave me one slide, and so I have one slide where we will discuss more. I want to get some information from you. So this is another dam in South Africa. This is a diamond. So we are seeing all the mines, whether diamond, whether bauxite, everywhere it is occurring. It's not that diamond is good. Diamond also doing that. Yeah, so this is in South Africa. So you can see the picture before. Looks very good. And the same picture after, you see, after the failure. After the failure. And this is more like you can see exactly where the bridge, dam bridge areas are, like the whole this area failed. This is dam bridge B. It breached here also. It breached here, and that's why in overall whole this area fell. Two places it breached. And there was also another, they are saying it's a erosional failure. Means it didn't breach the whole dam, but part of the things is there. So in diamond mine waste released between 4 to 6 cubic meters. So these numbers are very important, because when you do your emergency preparedness, you need those numbers. The motor traveled 7 kilometers over the dry land before reaching the reservoir of another dam. So when it goes there, your part is over. What they will take care of the things. So from that reservoir, you don't know where it is going. Where it is going. So you have to be careful when we do this kind of dam bridge model. Once it reaches the river, we are done. Okay, this is a gold mine in Australia. June 60 is happened in 18, 9th March 18, and you see right now these satellite images are the key. You don't need even to go there and look at that. It gives us the very good things. So pre-failure and post-failure, you can see that, like dam bridge, very good, very, looks like it may be kind of a, so it's just mixed, maybe slurry and dry stack. Coming to failure in India, this slide is coming from Surabhi. So you see that it is 100 times higher than the conventional water dam. We know that because conventional water dam, we have like high level treat, while the tailings is not treated as a high. Like when we built a conventional water dam, you know how much effort is given. When you build a tailings dam, is how much effort is. Right now, a lot of effort. But in the past, you go there, we need a tailings dam. Okay, we can design it overnight and then start construction. So again, this all data is coming from her. So she's reporting that there was 76 ash pond failure. So mainly that led to the government, no more ash pond. That's correct. There is no more ash pond. 95% will be utilized. That means no more ash pond.
That 5% itself is some million tons. Sir.
Some million tons. No.
That is more than the red mud production in India. That 5%.
Yeah. So this ash pond definitely is the cause in India. It's the main cause. But somehow not reported, and now also India is taking credit that we are using the ash for everything. Yeah, so. And there are 17 incidents, she's saying, between 1 year. So it's not that. It's now better, so it's still going on. And these definitely loss of human here also, the animal lives, and significant impact on the land, the environment. That's what our goal here is. What are the environmental considerations? When it failed, definitely it is going to affect. Before failure, you can say that we are very good, but you have to make sure it doesn't fail. When it failed, you just hold your hands off. I cannot do anything. It's all depend on how environment will take it, you see. So that's why we have to be careful. And some more here, like again, this one is the pond as failure, and this is the caustic pond. I think if anybody wants to tell something more about that, you have information, is very welcome. Because I also want to know a little bit more, but if it is confidential, you guys cannot say anything, that's also. But if you have any information like which is published, you can tell us that, like especially the caustic pond. Because of that, I read, and also I am very concerned here, like this caustic pond when it fell, so that water which is saying the skin it can affect your skin, it went out, no? So, you want to say something or no? Anybody else? Any idea, like any further information that will be helpful to everybody, because we should know that. Anything like it fell in 2023. So is there any like studies why it fell and what's the reason? Anything available? Like
I can guess. There was a rain. The time fails before that night.
Yeah.
One day before, there was a heavy rain, which exceeds the free road. So they might have cut the upper portion of dam to release the water, like spillway.
Okay.
That's the reason made this dike collapse, I think.
Okay. So there was heavy rainfall,
Heavy rainfall.
and because of the rainfall,
Suddenly increases inside.
yeah, so suddenly water is increasing.
This spillway.
And then they excavated some of these
Upper part, exactly.
so that allowed water to go into the
Outside.
No, not only outside, also into the dams. And then they washed away the dam.
Yes.
Okay, I think that's kind of looking at this.
And because the core of the dam was made of fly ash,
Core of the dam was the
it
fly.
was much like that, no?
Yeah. So that like this brown, this is mostly fly ash.
Fly ash. So it is full of fly ash is a powerful material.
Yeah.
So when it comes with in contact with water, the entire fly ash in the dam,
Yeah.
it took the entire fly ash.
So again, like that's why I'm focusing. You can use any material, like it's up to you, but you have to make sure that that's a strong material that can resist. If any flow, anything, it can resist. Not that it comes contact with the water, it will just wash away. So then that's not a good material. That's like a weak material. I think this one I found it was reported. Because this whole thing is coming from somewhere it is reported. Anybody, this one, bauxite residue, Muri. This is the one we are talking about, Muri. I think this one came into the press and pictures, maybe somebody did something. I got this information. And he said, you can see that before pre-failure in 9 April 2019, they had this picture from the satellite, and failure, post-failure, satellite image in 9th May, and so it fell in 9 April 2019. So before this is a before the failure, they had an image, and in the 9th May, they had another image. So you can see that it's a large area, but if you notice, there is some common. This corner is failing. Okay. So maybe in the corner you have to be very careful. Your thing put in the corner, the process and things like you do a 1D like a 2D model also, but the corner it is not exactly 2D. The 2D models are very good on the side slopes, but the corner it is really 3D. So you have to again look into different directions and see where is your weak or some pore pressure. Maybe in the corner region there is chance to have some excess pore pressure more than the other areas. You have to look at that. So what they are saying, the failed material comprised the entire extent of the forward pond area as well as one of the water storage ponds. The flow side was bounded by railway track towards the west, so it stopped. There was a railway embankment, it stopped there and travelled for a few hundred meters southward along the margin of the track. So it stopped at the track and then followed the track towards the village. The triggered mechanism of the event is unclear. So that is under our unknown category. But local reports have pointed to poorly constructed gabion wall. Where was the gabion wall? There was a gabion wall in front of the dam, or the gabion wall they are saying is the structure itself. Anybody knows where is the location of gabion wall?
Sorry, the gabion wall is around periphery of the dikes.
All periphery.
Yes.
So what we see here in front of this structure there was a gabion wall, and that gabion wall was mainly put for providing more support, correct? That was the main design, I hope so.
Yes.
But again, I mentioned you, the BORM is there we are doing, but I told everybody, the BORM will not protect if my flow is, BORM is just there. If this goes, it will go. So they are saying is the gabion wall, but I don't think like gabion wall is there. It's there because of the other thing. But once the flow starts, the flow is stopped there. You make an opening, it will flow. And with that pressure, even big waste dump also gone there. So, and due to undrained failure mechanism, they are still saying due to undrained failure mechanism based on some field observation. But again, still this is unknown, nobody knows what happened. But again, we know that this can happen also. So this also released some caustic water.
No, there was dry stacking.
It's all dry stack.
It
So
was
that's why
dry stack or above wet stacking, it was dry stack.
so everything which fell is the dry stack. No water was.
No.
Okay. We can not stop without two major failure which changed everything. So one of the major failure is Mount Poly in 2020. What Mount Poly changed, that it's released 25 million cubic meter of wastewater and tailings to the environment. So here you can see close to the tailings there is a big lake. So that changed everything. So when it fell and this whole material went to the lake, and then the discharge of toxic material, they are saying arsenic, lead, copper, nickel, these are all toxic, and went into this lake, Poly Lake, and there was a creek and there was another lake. This is the biggest dam failure in Australia. It came like highlight in all the news, all the TVs, all the medias, all the Australian Parliament, and everybody was involved. And they have to do a emergency rehabilitation plan, and the costs were so high. This cost of this thing was very high, and also some of the engineers who were responsible were penalized after the government penalized them. So that changed. So people were very cautious, and that's why I'm telling you, this is your dam. You have to be responsible. So you always think, no, this is my dam. I won't happen anything. I don't want anything to happen there. I will do good. So that's what I hope. All the knowledge you carry from all these 3-4 days, you go and see that. Check all your things, like they are doing good or not. So the Mount Poly is one, and this is the Bromadino, and we know everybody, and also Now lesson learned, we will little bit go into that also. But it also changed and we got now GISTM. If Brahmadina would not have happened, there would not have been any GISTM. But again, GISTM is good also. Though technically they are not telling anything because everybody thinks technically all the engineers are competent. They should do their work. We cannot tell them do what because this is vary from site to site. Technically you cannot come up with a one procedure. Technical things will vary from site to site. The site engineer should be responsible. He should be competent and that's why you are coming to attend these things. So get some more knowledge into it. And also know what others are doing. So that also helps you. But you have to do that. But other guidelines which management should do, that can be for everybody. What the operators should do, that should be for everybody. That's why those GISTM guidelines is for them and also make sure you take care of everything. This is a very good document. I'm not going more into the details, but I have given you the link. You go to this link. This is a very good website. I always refer that. Here you can see what is again they put data here when there is some information. Without information it will not come to here, but here you will see almost they go back to 1900. All the whatever reported incidents are recorded here in this website. You can see here so far they are saying 1, 2, 3, 4, 5, 6 has happened, and this one in Malaysia. Toxic water flooded workers' home, and again how much it releasing, they don't have information. This what is this year. Over potential cyanide contamination of one river. So cyanide is also highly toxic. I know that. It is maybe similar to your caustic water thing. Cyanide is very toxic. So it went to the river. Then the second one is in the Indonesia. The tailing outflow flooded the one industrial park, and also 3 workers who are working there lost their lives. Then another in Bolivia is a mudslide that buried the home and animals. 47 homes were completely destroyed and 2 deaths are reported. Then one in Zambia, this acidic mine influent spilled into the stream in a massive fish kill. So went into the river and a lot of fish died. The river serves as the primary source of drinking water in that area. So you know, like also in your close to your locality, if there is any river, you have to be cautious because the river water people are doing, and if it is contaminated. Same thing also in Ghana, and the last one this year was in Myanmar. Myanmar was a landslide, submerged more than 50 homes up to 2015. So Myanmar was a big incident. That happens this year in January. And so we stop here. But again, we will little bit again go more into the, like I am thinking tomorrow morning will be that, the lesson learned and whatever we are getting from that lesson learned, because that will help you carry with you and like what you do next. Any questions? Because I thought that I want to do some more discussion on the Indian L0, but looks like this maybe the country like those are like confidential. You guys don't want to discuss. Yeah, so that's his confidence there. Yeah, in the mining field, like I mentioned, we are working in a project where we have two tailings there, side by side. It means the distance between them is not even 1 mile. And when I started, both are at similar height. But one, we are expanding up to double the height. And others, we recommended stop there. Stop there. So, staying in the same site also it is different because of the deposition, how you maintain it. And the main difference I saw in both sides is the beach. But I have lot more things to show on that, but I am not allowed to do that. The clients do not want to show that because they don't want to tell people like what is the condition of this. Which we understand like this. Their own thing, whatever they want to do. Yeah.
Sir, I have one doubt. Hello. Sir, I have one doubt. If we construct a dam of 20 meter height, whether we go with a single slope on both the sides or we will go with these bombs and side slopes?
Like normally our each level we go up to 50 feet. That's what we say in our design. We do not go beyond 50 feet in one slope. So 20 meter you are very close, like you are like 60 feet.
Yes.
60 feet. But it helps, like you see, with your height, your load is becoming more and more. You go on increasing, the load is proportional to the height because it's the gravity load of the gravity. Like I am not going into this foundation.
So I am asking about parent dike.
That's what I'm saying. In the parent dike, you increase your height, the load to the foundation is more.
Sir.
But instead of say like 20 meter one slope, you divide it into 10 meter and 10 meter.
Sir.
Then you are increasing this, like the area you are loading is increased now because you will have a offset. In your first level, then you have an offset, you go there. So definitely, if you see the load per unit area is now reduced.
Sure.
Compared to 20 versus 10. You see? So those are the advantages.
Sir, on the other hand, if you see, by increasing the providing this power and increasing the basket, in the rainy season, by whatever language, we are allowing the power to increase by decreasing the effectiveness and decreasing the factor of supply.
Yeah.
So, it contradict the situation.
No. The pore water pressure, whether you go with like one layer, one slope, or you go with a two layer.
Sir.
With a two layer, definitely the front one, the one which is in the front, that's near the toe. That's there, the water load will be less because it's only 10 feet. But deeper one definitely will be the same as the before, because if you do a 120 feet, deeper one will be before. But in the second level, definitely if you have already put some tailings material on it, the load is going to this tailings rather than going into the foundation. So you are also having some extra benefit there. rather than if you do like a 20 feet one.
Sir, yes, we can use tailing material on first raising.
Again,
Yes.
you can use tailing material, but again you have to use the sand tailing material. It has to be sand because the underflow sand can be used on raising the structure, because the structure has to be free drained. We do not want any undrained material put there, like creating, because the free drain means even if water will enter, water will easily pass away. Water will not stay there. Because once water stay, when you are going to the next load, that will cause problem to this lower structure.
Sir, if the foundation is clay, it will not allow water to pass through it.
Which one?
Clay.
If foundation is clay. Yeah, if foundation is clay, I think you have to be more cautious on that. That's why in clay foundation, upstream is better than the downstream, because downstream all the load is taken by the clay foundation, while in the upstream load is again divided, because you are also your tailings also taking some load, not that every load is transferred to the foundation. So for the clay foundation, downstream or central line is not better than the upstream.
Sir, can you improve the foundation soil?
Yes, you can improve, like again depending on how thick is your clay. For example, this Mount Poly, when it fell, like the answer came that they had a 3 feet of clay below the foundation. If they could have seen that, they could have excavated it and put good material on the foundation. We do that. When we do the foundation, most of the site I have visited, it's the mining like mountain. So our foundation is rock always, most of the time. Foundation is rock. But in the coal plant or ash pond, there you may not find rock. So you find loose soil or clay, like depending on how thick that is. You can improve your foundation. Even in the clay also, if there is some water in it, that also can be dewatered, like they are using
By adding soil, by adding muram or sand to the clay,
Yeah.
that will also.
Any road, when we design the road, how we look into the subgrade, correct? Our 5 feet of, like in my all road design, I look into, I see that my 5 feet of subgrade should be good. If within the 5 feet I see any this kind of dispersive soil or expansive soil or even clay soils, I remove it. I said remove that and bring back good soil and compact it. So same thing we do also in the foundation, like a lot of building foundation, people do that. Otherwise how they are raising like big structures even in the clay, like they are putting deep piles. Those pile goes into the strong layer and put this there.
But here we can't add up to the piles. In tailing case we can't add up.
No. For tailing case you don't need that, because the load is not that high compared to like your building. Building loads are very high. Tailing load is not that high. The tailing problem is actually not the material, not the thing. Tailing problem is the pore pressure. Put a good drainage system. Make sure your material is drained, like the dam material is drained, and drainage. Put good drainage.
Sir, I have one doubt. If a parent dike with raising is already made without internal drainage system, later we found that this.
We need the drainage.
Now we want to.
Now we cannot do much, but put some piezometers, monitor it. And if the piezometer is telling you that it is rising, then first thing is stop. Don't load it more because it's rising now. You load it more, short time everybody will be happy. Yes, I am the space. I can put it here. But next time when it fails, then everybody will come to you. Why you tell us to do that? You see? So monitor it. If you cannot do anything, you can still monitor it.
But on later stage, we cannot provide any internal drainage.
Internal drainage to provide will be very difficult. Correct. You cannot do that. But you can monitor it. And monitor it time to time. Like that's why we said mostly if it is on the old tailings, like all these stages you are putting in the old tailings. So you can easily do the CPT. The CPT can go through that tailings and tell you how it is changing with time.
Okay, sir. If we will put piezometers at different levels and parietic line is what is above the toe of the die, downstream toe of the die, what we have to do in that case? What action
No. First you have to put piezometer.
Okay.
Piezometer will tell you where you are. Okay? You have the pore pressures. Then go back. Do your stability analysis. In the stability analysis, use those pore pressure value and make sure you are still getting 1.5, your factor of safety. But if there is a like you see the phreatic surface, I don't think there is really phreatic, like we are assuming that. But in normal, groundwater doesn't go from a higher level to the lower level. That's not groundwater. The groundwater flows laterally. So when you see that kind of thing, here it is very high, here is very high. So these are like showing, these are not a reserve, like a permanent groundwater table has been created. So these are locally some excess pore pressures. That's why you are seeing high value there, low value here. So water is not there, but if those pore pressures are still good to your stability and it is still showing, because you will clearly know that it is not a drained, it's still on drained. Because of on drained you are seeing those higher pore pressure. Otherwise, why you will see high pore pressure? And again, it's not just one time you are monitoring. You monitor it for 6-7 months or even for a year and then see what the trend. Just one time you are getting a value can be different, but you monitor the trend. The trend is important. The trend is showing going up on drain because it is not draining. But if trend is going down, then that means it is draining. But the soil can be fully drained, partially drained, completely undrained. You can have this kind of thing. Again, fully drained is all saturated. Below the water table, fully drained, if it is fully saturated, then it is fully drained. But most of these tailing soils are not fully saturated. They are partially saturated. That's why it's behaving like a on-drained material. And pore pressure is rising because the water has nowhere to go. If you are loading it, you are getting higher pressure. And once you see your factor of safety has gone down, then you have to come back to the table. I have to do some remediation before I do anything to this.
Sir, you are telling with this pore water pressure, if this stability or factor of safety is 1.5, more than 1.5, then it is okay.
Then it is, you are okay. But you have to still monitor it. And what we do, we have to come like, suppose if you are 1.5, you should not, it's not okay. Because next time it will go down. We have to keep it little higher than that. Because 1.5 is the one, like it should not go below that. So, but again, if it is rising and you are getting 1.5, then there is trouble. You see, because another value, another little bit rise, it will bring down to less than 1.5.
I also heard something, if the phreatic line exists somewhere on the body of the dike, downstream side, the water will take heavy material from the core of the dike.
if there is seepage, yeah, if there is seepage happening, then definitely the core is going. Yes, yes. And when it seepages, your settlement is also occurring. The water is going out. Settlement is occurring.
Decrease the weight of the dam and
Again, lot of things. If we do not allow, like when we go do inspect, if the seepage is occurring, we have to do something there.
what action we have to take, sir?
Again, we go back and like for if there is some erosion, if we find some erosion is doing that, then we little bit put some more material on it and make it better and
It's a rock tower using.
yeah, to area and put again this kind of gabion. We don't put like a gabion wall, but we put like a small bore which can be fully drained. And again, we normally collect those water and see that water how there will be like it's not exactly mud is coming out. Most of the things is water with some suspended particle.
Actually, sir, our husband has this type of difficulties.
Yeah.
We didn't provide any internal relay system in terms of sand, chimney, sand blanket or ground toe to either to our parent dike or to our
Correct,
raging
correct.
dike.
So that's why the asphalt helps more because
But whenever there is a rain, we are not finding any water above our house. So where this water goes, we don't even know.
you don't even know because they are mostly going down.
Going down and sir, we are
So,
not finding any water from outside.
then when going down,
I have so many water.
your asphalt is all lined asphalt or they are not lined?
I don't know, sir, the team involved at that time projected.
You don't know whether it is lined or not.
But in drawing, it was showing the liner inside pond. Liner with PCC above the liner.
Because the liner, one of the liner is good, but liner will also like create the pore pressure. If more water is
The
going
drawing
here.
shows liner inside pond throughout the dike
Now-
also, base and dike.
With
That's
a-
why they are not provided.
No, what we can do with existing tailings dam, you still can do those diverse channels surrounding the tailings. You can put some berm there so that do not allow any flow to go into the tailings and divert all the surface flow going into the tailings with sides. But any rainflow going over the tailings, if you do not have any drainage system there, like mostly if you can see if you can make some slope there on the upper surface, maintain a slope on the upper surface so the surface water goes out, and put some on your berm like in the dams, put some good channels, riprack, so allow them to go rather than going inside.
Okay, sir, thank you.